Hello viewers and welcome to the lesson. This is mathematics for grade 9 KJSEA examination. So let us work out all these questions as we continue to prepare for the forthcoming examination. Don't forget to go to the description of this video. That is where you get the link to download the question paper. So let's go through the first section of the paper. So the first section is here. Question 1, without using a calculator, evaluate. Without using a calculator, you're supposed to evaluate this question. So the instructions are very clear. Without using a calculator. So you're supposed to ensure that all the workings are there. Ensure that you do all the workings manually. In case there is evidence of the use of a calculator, you are likely to lose a mark for this. So for this question, let me start with the numerator. So the numerator. So for the numerator, you have negative 2 into brackets 5 plus 3 minus 9 divided by 3 plus 5. So you can see here we have different operations. We have addition, we have bracket, we have subtraction, and we have addition. So we must apply the rule of BODMAS. So the rule says you must start working out the brackets first. So you work out whatever is in the bracket. So whatever is in the bracket is 5 plus 3, that will give 8. So therefore you shall have negative 2. When you get rid of that bracket, you remove it, you multiply, 5 plus 3 is 8. Then subtract 9 divided by 3 plus 5. The next operation that follows is division. Let us work out division. Where do we have division? You can see we have 9 divided by 3. 9 divided by 3. So let me indicate that. So we have this one. So we have to work out that one. So 9. So we have negative 2 times 8. Then subtract 9 divided by 3 is 3. And then plus 5. The next operation from there is multiplication. So multiplication is here, negative 2 times 8. That will give negative 16. Then minus 3 plus 5. So from there you can see we have subtraction and addition. Which one comes first? Addition comes first. So you can rearrange this one. Negative 16, subtract 3 plus 5. You can rearrange it like this. You start with 5. Then we have 5 is positive, so that is a positive. Then you have subtract 16, subtract 3. So I've just rearranged, maintaining all the signs. So negative is there in 16, negative is there in 3, positive 5. So what is this? 5 subtract 16. We start with that. 5 subtract 16 will give negative 11. So negative 11, then you subtract 3. So what will this one give? So negative 11 subtract 3 will give negative 14. And that is the solution for that numerator. So we go to the denominator. Denominator is the next. So denominator. So for the denominator we have negative 3 multiplied by negative 5 plus minus 2 times 4. We use the same rule, BODMAS. So multiplication, and then we go to addition. So when you look at the signs that we have here, we have this negative. We only have multiplication. Just look at this. I'll just put the bracket to indicate that. So you have this multiplication, and then you're going to add. So negative 3 multiplied by negative 5. Remember, negative multiplied by negative will give positive. So we have -3 times -5. That will give, this will give positive 15. So that will give positive 15. Then plus -2 times positive 4. A negative times a positive, that will give negative. So you get -8. So -2 multiplied by 4, that is -8. So this one gives 15. This is positive multiplied by negative. Positive multiplied by negative is negative. So this is 15 subtract 8, and that will give 7. So now you have the solution for the numerator and the denominator. Now get the answer. Proceed and get the answer. So numerator, which is -14, divided by the denominator, which is 7. And this one, when you simplify it, you will get 7 divided by 7, 1. -14 divided by 7, that will give -2. So the solution is simply -2. So that is D. We go to the next question, that is question 2. Go to question 2. So question 2. A solid cube has its edges measuring 3.25 centimeters long. Calculate the volume of the cube for significant figures. So a solid has its edges measuring 3.25 long. So you know the properties of a cube. A cube has all the sides equal. All the sides of a cube are equal. How do you get the volume of a cube? So volume of a cube is given by side times side times the side, or length times the length, because in a cube all the edges have equal length. So this will give 3.25 multiplied by 3.25 multiplied by 3.25. That is what will give the volume. So when you multiply these, you will get 34. You get 34.328125 centimeters cubed, because this volume. You are supposed to give the answer correct to 4 significant figures. So how do you get significant figures? You calculate significant figures from this number. This is the correct one significant figure, 2 significant figures, 3 significant figures, then 4 significant figures. So you want that number up to that point. So 1 significant figure, 2, 3, and 4 significant figures. So you round off this one. You have 34.3. Now check the next number after 2. That is, if it is 5 or more, you're going to add 1 to 2. If it is less than 5, you just leave it as 2. Now that this is 8, you're going to add 1 to 3. So you get 34.33 centimeters cubed. So that is question 2. Let's go to the next question. Go to the next question. That is question 3. A cubic container has a volume of 7893 centimeters cubed. Find the height of a cuboid of the same volume if its base measures 21.3 centimeters by 14.5 centimeters. Leave your answer to 1 decimal place. So you have a cubic container, you're given the volume, and then you're supposed to find the height. You're given the base measures 21.3 and 14.5. Now for that question, you need to know how do you get the volume of a cube. Volume of a cube is given by the length times the width times the height. So you already have the volume. The volume is 7893. So 7893 is equals to the length. One of the measurements is 21.3. So 21.3. Then times the width. The other measurement is 14. This is 14.5. And then multiply by the height. That is what we're supposed to do. So now you get this is 7893 is equals to, multiply this, 21.3 times 14.5. What do you get for that? That will give 308. That will give 308.85. Then multiply by the height, you get h there. So from here, for you to get h, you simply divide both sides. So you have 7893 is equals to 308.85 h. So divide both sides by 308.85. Divide this side. Sorry, that decimal. So this is 308.85. So when you cancel these, you divide these out, you remain with h will be 7893 divided by 308.85. And this will give, this one will give 25. You get 25.556. And you're supposed to give this one, leave your answer correct to 1 decimal place. 1 decimal place means that we need this number up to that point. That is correct to 1 decimal place. So when you round off this one, correct to 1 decimal place, this will be 25 point. Look at this number. After 1 decimal place, this is 5. So you're going to add 1 to 5. So you get 0.6 centimeters. So 25.6 centimeters. That is the solution. Now for the other one, we got the answer is 34.33. 34.33. Got to mark that. So from there we can go to the next question. And the next question is question 4. Let's go to the next question. Question 4. So question 4, evaluate. Supposed to evaluate. So for this particular question, you're going to use the indices. Going to use the indices. That is what you're going to use here. So 343 a cubed divided by b cubed, everything you get the cube root. So we shall simplify 343, and this one we can write it in power form and get this is what you're going to get. If you divide this one by 7, 343 by 7, you get 49. 49 divided by 7, you get 7, and then 7 divided by 7, you get 1. So this will give 7 times 7 times 7, which gives 7 cubed. Now, this is what you're going to have. After doing that, you shall have the cube root. Going to have the cube root of 343 is 7 cubed, and then multiply by a cubed divided by b cubed. Now for us to get the cube root, this is what you're going to do. We are going to write this 7 cubed is the same as 7 multiplied by 7 multiplied by 7. Then times a cubed is a times a times a. So I want you to look at that is 7 cubed, and then this is a cubed. Then everything divided by b cubed. And b cubed, let me write this one, b cubed will be the same as b times b times b. You're getting the cube root. So now after that, when you're getting the cube root, you do group them into, or you classify them into groups of 3, like the way you can see this. So for you to get the cube root of 7 times 7 times 7, for every group of 3, you pick 1. So to get the cube root of this, for every group of 3, like this 7 times 7 times 7, that is a group of 3, you pick 1. Like that. Then you go to the next, a times a times a. For that group of 3 again, you take 1. And then for the denominator again, for this group of 3 b's, you take 1. By doing so, you have obtained the cube root. For every group of 3, To get the cube root, just pick one. So this is 1, 2, 3. Pick one in each case. So this will give 7 times a, which is 7a divided by b. And that is the solution for that, which is a. We go to question 5. Question 5. So I'll do question 5 here. So you're supposed to find the cube of 0.7604. That is question 5. So cube means you're getting 0.7604 cube. Now, when you go to the tables of cubes, remember you'll not get these the way it is. The tables of cubes runs from 1 to 9.9. So you have to write this number in standard form. 0.7604 in standard form, it will be 7.604 times 10 raised to power. Look at where you have placed the decimal. So to go back to where the decimal was, you move one step backwards. So one step backwards is -1 from here to move where the decimal place was. So now you are getting the cube of these. So you're supposed to get the cube of each of them. So from the table, get the cube of 7.604. 7.604. So we go to the table. You have the 4-figure mathematical table. So make sure you have that 4-figure mathematical table. So go to the tables of cube. You see this is a square root. Go to the tables of square root, that is square root. So you have cube. So you want 7. You want 7.604. 7.604. 7.604. So you can see it is here. Let me take it up. So 7.6. 7.604. 0 is the first column. 7.6. Note that number that is here. So you note that. You note that number. 7.60. 7.60 is 439.0. 439.0. That is a cube. And then 4. You go straight to where 4 is. So 4 is this column where we have add. So you drop down with that column. So 4 is here. So you're supposed to add. You're supposed to add 7. You add 7. So you add 7 there. So you get 439.7. 439.7. That is what you're supposed to do. So for this one, using the table, you'll get 439.7. That is the cube of 7.604. Then the cube of 10 raised to power -1. Remember that 10 raised to power -1 is the same as 1/10. So therefore, you need to get the cube of 1/10. 1/10 times 1/10 times 1/10. That is 1/10 cube. And this one will give 1/1000. 1 divided by 1000. So the cube of 7.604 is 439.7. The cube of 10 raised to power -1, and 10 raised to power -1 is the same as 1/10, is 1/1000. So this means you're going to have 439.7 divided by 1000. And this will give, so 1, 2, 3. 3 step backwards. 1, 2, 3. The decimal will be there. So you have 0.4397 as the solution for that part. Power 6, which is the same as 1 divided by 10 raised to power 6 is 1,000,000. It's 1,000,000. So in simple terms, 10 raised to power -6 is the same as 1 divided by 1,000,000. So you get the cube root of 1/1,000,000. 1 divided by 1,000,000. what is the cube root of that? It will be 1 divided by 100. Remember this, that 1 divided by 100 times 1 divided by 100 times 1 divided by 100. That is what gives 1 divided by a million. So the cube root of 1 divided by a million is 1 over 100. So this is now going to give us the solution, because the cube root of 731.9 is 9.012. The cube root of 10 raised to the power negative 6 is 1 over 100. So when you multiply these, you get 9.012 divided by 100. And this gives, when you divide these, so you get 0.09012. That is what you get, 0.0902. So that is the answer. So now go to the paper. So here it is. So I can see the solution. The solution is here. So this is the solution for that part. So now we can proceed to the next question. The next question is question 7. Question 7 is next. Question 7 is the next. So question 7 is a question on indices. So 4 raised to our x plus 1 is equals to 32. You're supposed to solve for x. So the first thing you need to do is to look at these bases. So look at 4 and look at 32. Can you be able to express them to the same base? Yes. Why? Because 4 can be expressed to the base of 2, and this will be 2 squared. Then 32. 32 can also be expressed the base of 2 in power form. This is how we do it. Just take 32 divided by 2, you get 16. 16 divided by 2, you get 8. 8 divided by 2, you get 4. 4 divided by 2, you get 2. Then 2 divided by 2 is 1. So this will give 2 times 2 times 2. 2 times 2 times 2 times 2 times 2. This is a 2 to the power 5. 1, 2, 3, 4, 5. 2 to the power 5. So 32 therefore is 2 to the power 5. Just substitute this. So 4, or from here, 4 is 2 squared. And then you have x to the power 1. Don't forget that. X to the power 1 is equals to 32 is 2 to the power 5. So when you open this bracket, you get 2. This is a 2x plus 2 is equals to 2 to the power 5. Now after doing that, and you can see the bases are the same in both sides of the equation, simply pick the powers and equate them. So you take the powers, 2x plus 2 is equals to 5. And then so for x. So for x, you want to eliminate plus 2, so subtract 2 from both sides. You can simply take it to the other side. So you get 2x is equals to 5 subtract 2. When you take positive 2 to the right hand side, or simply subtract 2 from both sides. So this will give 2x is equals to 3. And therefore x will be dividing both sides by 2 in order to remain with x. You get 3 over 2. And 3 over 2 is the same as 1.5. So 1.5 is the solution. We go to question 8. Question 8 is the next. You're supposed to express this number in standard form. The number is 0. How many zeros are here? 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. 6 zeros. So 1, 2, 3, 4, 5, 6. And then 9148. Like that. This 6 or 7, 1, 2, 3, 4, 5, 6. Okay, I was just confirming the number. Now, how do you write a number in standard form? A number is said to be in standard form if it is in this format. A times 10 to power n. When the number is in this format, we say that it is in standard form, where A should be in this range. A should be in this range. So A should be less than 10, and A should be greater than or equal to 9. It can be greater than or equal to 9. So you're supposed to write A should be in that range. It should be less than 10. Of course, it should not be 10, but it should be greater than or equal to 9. So any number that is between there, it is actually the number between 1 and 9.9999. So that is what we mean by this. The number A should be between 1 and 9.999 because it's not supposed to be 10. So how do you write this number in that form? And then n should be an integer. An integer is a positive or negative number, including 0. So when I look at this number, I can insert the decimal here so that I can have 9.148 like that. And insert the decimal there, have 9.148. Then time 10. Now to know the power that you're going to put there, just look at where you place the decimal and then move up to where the decimal was originally. Where was the decimal? It is here. So you move how many steps to that place? You move, these will be 1, 2, 3, 4, 5, 6, 7. So those are 7 steps to the left. From where the decimal point is, there are 7 steps to the left. So you place the decimal here. So to move is 1, 2, 3, 4, 5, 6, 7. So 7 steps backwards. So that is -7. And that number is written in standard form when it is like that. We go to the next question. Next question is question 9. And question 9, very easy. What is the logarithm of 100 or 1,000? What is the logarithm of 1,000? So 9, logarithm of 1,000. So to get the logarithm of 1,000, you need to understand what is logarithm. Logarithm of a number is its index. Its index. Logarithm of a number is its index. So you need to write 1,000 in index form. So what is 1,000 in index form? 1,000 in index form is 10 cubed. 10 cubed. 1,000 is 10 cubed. 1,000 is equals to 10 times 10 times 10. That is the number in index form or in power form. So once you do that, now you can see we said the logarithm of a number is its index. So when you write that number in power form or in index form, you identify the index. The index will be the logarithm. So the index here is 3, and therefore its logarithm is 3. That is 1,000 written in power form to the base of 10. So logarithm is 3. Question 10. Question 10 is still question on logarithms. It's still a question on logarithm. Write logarithm of 100 to the base of 10. So logarithm of 100 to the base of 10 in index form. In index form. So to write this in index form, this is what you're supposed to do. I'll give you an example. If you have a number like logarithm of let's say m to the base of let's say 10 is equals to k, this equation is said to be in logarithmic notation. This is in logarithmic notation. If you're required to write this one in index notation, what do you do? In index notation, what do you do about this? You simply take 10 to power k. That should give m. That should give m. So that is how you write. Now this one is in index notation. index notation. So now I want you to look at what we have here. This is 100. So 100 is the same as 10 squared. So 10 squared is 100. As simple as that. So when you look at these, you can also simplify it to say that logarithm of 100 to the base of 10 is the same as logarithm of 100 is 10 squared. 100 is 10 squared, like that. And you can see the power. We say the power or the index is the logarithm. The logarithm. So logarithm of 100 to the base of 10, therefore, is 2, because we said the index of the power is the logarithm. So from this, we can say that logarithm of 100 to the base of 10 is 2. Where did we get 2? From the power. 100 is the same as 10 squared. So from here now, you can use this. You can use this in index notation. This will be 10 squared is equals to 2. That one is the required solution. That is the required solution. 10 squared is equals to 100. It's there. Question 11. Use mathematical tables to evaluate. Supposed to use mathematical tables to evaluate. So what are you evaluating? You have the root of 230.5. So this is question 11. The root of 230.5, like that, plus this is a 12.54 squared. So for this one, we are supposed to use the tables of square roots and the tables of squares. So we start with the root of 230.5. Now, since the tables of square roots give values from 1.0, is the square root of numbers from 1.0 to 99.999. So we can write this one in such a way that we'll be able to get its square root. So this is how I'm going to write it. So I will write it as this is a 2.305, 2.305 standard form, multiplied by 10. Look at where you've placed the decimal point between 2 and 3. So to go where the decimal point was originally, so this is 1, 2. You move 2 steps forward. That is 2 steps forward is 2. So you're supposed to get the square root of this number. So from the tables, we get the square root of 2.305. So we go to the table right away. So the tables of square roots. So tables of square root 2 point. We zoom this. So you're supposed to get the root of 2.305. 2.305, square root of that. So we'll get the number 2.30 up that point, 2.30. That number is here. 2.30, you read this number. So that will be 1.5166. Then 5 is remaining. So you go straight up to the column where we have 5. Up the column where we have 5, you're going to add 16. This is the column where we have 5. If you go, you scroll up, you have 5 is here. That column where you're supposed to add. So 5 is there. So let's see, 5 is there. So you add 16. Sorry, you add 16. The number you're supposed to add not 5 but 16. 16. So when you add 16, this will give 1.5182. 1.5182, like that. That is what you're supposed to get. Now remember, we can just finish the question on this place. So we have, we are getting the square root of 2.305 times 10 squared. So the square root of 2.305 is 1.5182. Then the square root of 10 squared is 100. So the square root of 100 is 10. 10 squared is 100. So square root of 100 is 10. So these, when you multiply 1.5182 times 10, these will give 15.182. So that is what you get. Now we go to the other one. Remember, we're supposed to add 12.54 squared. So let me copy these now. So this is a 15.182. 15.182. 15.182. So now this one has given us 15.182, like that. So now we want to get the square of 12.54. The square of 12.54. What are we going to do for that? So 12.54 squared. Again, we write that one in standard form. This will be 1.254 times 10 raised by 1. You're getting the square of that number. So that means you're going to get the square of 1.254 and 10. So we go to the tables of square. Tables of square. Go to the 4-figure table. So the tables of squares. So tables of square is here. So you're getting the square of 1.2. Let me zoom these. So 1.254. 1.2 is here. Then 5 is there. So 1.25. Up to that, you will get, either one will give 1563, 1.56, 1.563, like that. So that is 1.25. Remember, we are remaining with 4. So column where you have 4 is there. So drop down. What are you supposed to add? You're supposed to add 10. So you add 10 there. So this will give 1.573. 1.573. So that is a square of 12.53. This will be 12.53 squared. Now that is what you get, 1.573. So you go back. So now for this one, we have already established this, that the square of 1.254 will be 1.573. Then the square of 10. The square of 10 is 100. 10 times 10, 100. So this will give, when you multiply this by 100, you get 157.3. That is how you get it. So now you're supposed to add now the 2. So you take this now, get the answer, you add the 2. So now the answer is, you take 15.182, because we are solving this, you're supposed to add now. So the square root of 230.5 was 15.182. Then the square of 12.54 is 157.3. So when you add that, you're supposed to get 172.482. And when you're adding the decimals, remember you're supposed to arrange them like this: 15.182 plus 157.3, like that. So 2849. This is 12. This is 7. This is 1. So that is how you're supposed to do it. So that is 172.482. So the solution is D. So that is how you're supposed to do that. Question 12. Nyambura, 𝐊𝐂𝐃𝐄, and 𝐏𝐑𝐃𝐄 shared the profit of their business in the ratio 5:7:9, respectively. If 𝐊𝐂𝐃𝐄 received 84,000 Kenya shillings, how much profit did the business yield? So you have the ratio of Nyambura, 𝐊𝐂𝐃𝐄, and 𝐏𝐑𝐃𝐄. So Nyambura, I'll denote that by N, 𝐊𝐂𝐃𝐄, and 𝐏𝐑𝐃. The ratio is 5:7:9. So what we need to get, because 𝐊𝐂𝐃𝐄 received 84,000 shillings, we need to get the fraction 𝐊𝐂𝐃𝐄 received, or the fraction of 𝐊𝐂𝐃𝐄 that was used to calculate this profit. So to get that, we get the total of this ratio, which is 5 plus 7 plus 9, which will give 21. So the fraction for 𝐊𝐃𝐄 will be 7 divided by the total. So that means if we let the total profit yielded by this business to be X shillings, then it means 7 divided by 21 of X, of that profit, that is 𝐊𝐃𝐄. If we want to get the 𝐊𝐃𝐄's amount, we get 7 divided by 21 multiplied by X, where X is the total profit. That gives 84,000. So now when we find X, X will give us the total profit yielded by the business. So how do we get X? We make X the subject of the formula by multiplying both sides of this equation by the reciprocal of 7/21, that is 21/7 times 21/7. So this one will give X to be 84,000 times 21 divided by 7. Now this will give the total amount of profit the business yielded. And this will give Kenya shillings 252,000 as the total profit yielded, 252. So that is how we're supposed to do that, by simply letting the total profit shared to be X. Then since 𝐊𝐃𝐄 received 84,000, we simply get the fraction 7/21. That is a fraction 𝐊𝐃𝐄 received of the total. 7/21 of the total profit X. That should give 84. So we get X. So that is all about question 12. We go to question 13. The internal measurements of an open rectangular container which holds 2.5 liters of water are 30 centimeters long and 16 centimeters wide. The thickness of the material of the container is 5 millimeters. Find the volume of the material used to make the container in centimeters cubed. So we read the question again. Need to read the question again for us to understand this properly. So the internal measurements. This one is an open rectangular container. It holds 2.5 liters. And since I can see the units are given in centimeters, and definitely when you get the volume, we get the volume in centimeters cubed, we need first to convert 2.5 liters to centimeters cubed. And you know that 1 liter is equivalent to 1,000 centimeters cubed. So what about 2.5 liters? This will be 2.5 times 1,000, and this will give 2,500 centimeters cubed. That is the volume. Then this rectangular container has a thickness. So if I can just draw a rough sketch, you can draw a rough sketch showing the internal measurements. So the internal measurements, that means it looks something like this. So let me draw a bigger one so that I can be able to show the internal measurements and the external measurements. So if I draw it a bigger one like this, just a sketch. So that is the bigger one. So the internal measurements, so these are some thicknessium. This is what I'm trying to draw. So that is how it looks like. So there is a thickness. The thickness is 5 mm. That is 5 millimeters. So 5 millimeters in terms of centimeters will be 5 divided by 10. So this one will be 0.5 centimeters. Remember that 10 millimeters is equals to 1 centimeter. So that thickness of 5 millimeters is the same as 0.5 centimeters. So that means this length here, this is 0.5. And then this one also here, this one is, let me draw this one properly. So this one here, this one is 0.5. And then because the internal measurements are given as 30 and 16. So this is 30 centimeters and this one is 16 centimeters. Remember the thickness is also here. So this is 0.5 as well. And also this one here, 0.5. So now, having that rectangle, because we are given the volume, the internal measurements first, because that is the volume, that is the one that holds water. This part that is here, the one that holds water. So we are going to calculate the volume. That will help us to get the height, because you can see we are given the internal measurements, that is the length and the width. And you know, for us to get the volume of this, we have to get length multiplied by width, multiplied by the height. So we don't have this height. We don't have that height. So we need to get that. So we're going to use the volume, since we have the volume of the water is 2,500 centimeters cubed is equals to the length. We are using the internal measurements because that is the part that is holding water. So this is the part that is holding water. And that one we're going to use 30 centimeters multiplied by 16 centimeters multiplied by the height. So this one will enable us to get the height. So when you multiply this, when you multiply that, this is what you're going to get. We will get 30 by 16. Let me just make this h the subject. So if you make h the subject, you want to get h. So you divide both sides by 30 times 16. Divide both sides by 30 times 16. So divide the right hand side by 30 times 16, the left hand side by 30 times 16, so that you can remain with h on one side. So this is what is going to give us h. So h will be, when you work out this one using a calculator, you get 5.208. 5.208 centimeters. So that is the height. And that is the internal height. Internal height, because we are using the internal measurements to get the internal volume. The question is, we are supposed to find the volume of the material. The volume of the material is this. This is the one that we need to get. These are the whole of this part that you can see here. That is the material that was used to make that container. This outer part here. That is what you are supposed to get. The one that I'm shading in yellow, that is what you are supposed to get. So in order to get that, we will use the volume. So the material, the volume of the material will be given by the volume, that is the external volume, minus the internal volume. That is what you're going to do. So for us to get the external volume will be given by the volume of the outer rectangle. And you can see, for us to get the volume of the external rectangle, we have to add everything from this point to this point. So you have 30. So you have 30 plus 0.5 plus 0.5. So that would be 30 plus 0.5 plus 0.5, which will give that 1 centimeters. So this is the length, that 1 centimeters. And then this other width here. So you have to get 16 plus 0.5 plus 0.5. So 16 plus 0.5 plus 0.5. So this one will give 17. So this one will give 17, like that. Then for this height, you need to be very careful, because for the height, remember, for the height, because this container is open at the top, the height has already subtracted the thickness below. There is some thickness that is here below, which has already been subtracted. So we got the height as 5.208. So now the height of the bigger rectangle, bigger cuboid, will be 5.208 plus we must add that thickness of 0.5, which will give 5.708. Now the whole of these 5.708. What we got was the internal height. And internal height, we have already subtracted the thickness. There's a thickness that is below, but at the top we don't have the thickness, but there's a thickness that is below. That is why the height of the outer or the bigger cuboid, we have to add 0.5. So therefore, the external volume will be given by 31 times 17 times 5.708. And then the internal volume, now we use the internal measurement, which is 30 times 16, 30 times 16, and then times the height. The height is the one that gave us the volume, which is 5.208. We already have the height there. The height is there. And already, if you noticed, we already have the volume of the internal part. So this one would definitely give, unless there may be a slight difference because of approximation of the height, but this one we already have it as 2500 centimeters cubed. It is already here. We are given the volume of the internal volume. So the external volume is what you're supposed to get. And when you multiply these, you're going to have that 1 times 17 times 5.708. These will give 3008.116. So now when you subtract these, we'll get the material. So the external volume minus the internal volume. So 3008.116 subtract 2500. So this one gives 508.116 centimeters cubed. So that is how you're supposed to solve that question. Question 12. Nyambura, Akinyi, and Jepto shared the profit of their business in the ratio 5:7:9 respectively. If Akinyi received 84,000, shillings. How much profit did the business yield? So question 12. So Nyambura, denote this Nyambura with N. Then we have Akinyi with A. And then ratio 𝐵𝐃𝐃. The ratio is 5:7:9. So Akinyi received 84,000. So let us see the fraction of this profit that Akinyi received. So using the ratio, you're going to get 5 divided by the sum of the ratio, 5 plus 7 plus 9. This will give 21. So the fraction of, who is this? Akinyi received. Akinyi is 7. 7. It is 7, not 5. Akinyi ratio is 7. So it is here. So the fraction Akinyi received will be 7 divided by 9 times the profit. And that is what is going to give what? Times the profit. That is what is giving 84,000. So that is how we get the amount Akinyi received. It is 7 divided by 9, that is a fraction, multiplied by x, where x is the total profit the business yielded. So the total profit. So this one will definitely give, if you want now to make x the subject, this will give 7 divided by 9x is equals to 84,000. So what about x? X will be given by, you multiply both sides of this equation by the reciprocal of 7/9. So multiply by this 9/7, this one by 9/7 in order to remain with x. So by 7/1 by 7/1 by 9/1 by 9/1. So you get x is 84,000 times 9 divided by 7. And this one is going to give nimekosea. No. 7/9 imetoka wapi sasa? Question 14. Supposed to express is a question. Before we go, the other question, the solution was 508.1. Supposed to be that. So express 0.123 as a fraction in its simplest form. The dots are on 1 and 3. So that means 1 and 3 are recurring. So how do you solve that question? You solve that question by letting the fraction, let the fraction be r, to be represented by, the fraction is r, and that r will be represented by 0.123. 1, 2, 3. When the dots are on 1 and 3, that means 1, 2, 3 is recurring. So 1, 2, 3. So recurring 1, 2, 3, 1, 2, 3, 1, 2, 3. That is the first equation. 1, 2, 3 is recurring. Now take that r and multiply it by 10. Multiply this r by 10. You know what happens when you multiply a decimal number by 10 or multiples of 10. So this decimal will go one step forward and you have 1 point. So have 1.23. Don't forget the pattern. What is recurring is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. So what we are targeting, we are going to multiply by multiples, r by multiples of 10. So we multiply by 10 if the decimal part is not uniform. Like for example, when I look at the first one here, look at this. This one and this one, the decimal part still is not uniform. So we shall continue multiplying. The next is 100r until, so we are multiplying the first one. So 100r means 1, 2. So you go 2 steps forward. So this will be 12.3. Look at the pattern, 1, 2, 3. So the next one, 1, 2, 3, 1, 2, 3, 1, 2, 3. Still, that is equation 3. Still, when I look at the three equations, look at the decimal part. 1, 2, 3, the first one, the second one is 2, 3, 1, the other one is 3, 1. No, not uniform. So now we continue. Now we started from 10R, then we go to 100R. Now we shall multiply R again by what? By 1,000. By 1,000. Multiply this R by 1,000. So 3 steps forward from the decimal place. 1, 2, 3. So you get 123 point. Look at the numbers. 1, 2, 3. Don't forget that pattern. 1, 2, 3. 1, 2, 3. 1, 2, 3 is recurring like that. That is equation 4. Now I can see there's something that is similar. Look at equation 1 and look at equation 4. The decimal part. 1, 2, 3, 1, 2, 3. So we stop at that point. And now from there we shall take equation 4. We take equation 4 and subtract equation 1. Equation 4, subtract equation 1. So we take 100R minus R. So 1,000R minus R is equals to, we take 123, subtract 0. Why am I subtracting 0? Because the decimal part is uniform. It is the same. Even if I write 123.123, subtract 0.123, I'll still get 123. So it's the same as 123. You just consider the whole number part, because that is the one that is different. So 123.123, subtract 0.123, that will give 123. 1,000R minus R is 999R. Is equals to 123. Remember, the fraction that you are looking for is R. So how do you get R? By simply dividing both sides by 999 by 999. So when you do so, by 991 by 991, so this R, not radius, R is equals to 123 divided by 999. You can leave it like that, or you can simplify it. If you simplify this, you get 41 divided by 333. So that is the way you're supposed to solve that. Question 15. The diameter of a cartwheel is 63 centimeters. Find the number of revolutions the wheel makes when the cart travels 0.09 kilometers, 9 meters. Take pi to be 22/7. So the diameter of the cartwheel is 63 centimeters. With that, we can find one revolution. Can be able to find one revolution. So one revolution is equivalent to the circumference of that cartwheel, because it is in the shape of a circle. And how do you get the circumference? By simply getting pi d. So that is how we get the circumference. So this will be 22/7 times the diameter. The diameter is 63. And this gives, when you multiply this by 7, 1 by 7, 9, this is 22/9, this will give 198 centimeters. So one revolution is equivalent to 198 centimeters. That is a circumference. Now we need to find the number of revolutions the wheel makes when the car travels 0.09 kilometers, 9 meters. So that means we need to get the whole of this distance, 0.09 kilometers. First, we convert that into centimeters. So how many centimeters make one kilometer? So 1 kilometer is equivalent to 100,000 centimeters. So what about 0.09 kilometers? You simply multiply that by 100,000. And this will give 1, 2. This is 1, 2. This will give 9. This will give 9,000 centimeters. Then we have 9 meters. 9 meters, convert that one into centimeters. 1 meter is equivalent to 100 centimeters. What about 9 meters? You simply multiply 9 by 100. So that will give 900 centimeters. So now the total distance will be 9,000 centimeters plus 900 centimeters, which gives, this will give 9,900 centimeters. So that is the total distance. Now, how do you get the number of revolution? You simply say if one revolution is equivalent to the circumference of the circle, which is 198 centimeters. So what about this distance? That is 9,900 centimeters. How many revolutions will that be? So you simply divide 9,900 divided by 198. And when you divide this, you will get 50 revolutions. 50 revolutions. And that is how you're supposed to solve that. Question 16. Kamau is 5 times as old as his son. 15 years from now, the son will be half as old as his father. Taking the present age of the son to be X years, find the present age of the son. So let us solve that question. So we have now, the age now, and the age in 15 years time. So let us make this small table here. So we have Kamau, and we have the son. So we are taking the age right now, the present age of the son, to be X. And we're given that Kamau is 5 times. So 5 times means 5 times X. So the age of the father right now is 5X. Then we go to the other statement. 15 years from now. 15 years from now, Kamau will be 5X plus 15 years. The son will be X plus 15 years. You told that the son will be half as old as his father. So that means the father will be twice as old as his son. So this means that if I get Kamau's age, which is 5X plus 15, I divide by the son's age, which is X plus 15, I'll get this as 2. Why? Because 15 years from now, the son will be half as old as his father, and that means that the father will be twice as old as his son. So now, having this equation, you can simply solve for X. So just put this one, 2 divided by 1, then you cross multiply. 5X plus 15 times 1, you get 5X plus 15 is equals to 2 multiplied by X plus 15. So 2 times X, you get 2X, then 2 times 15, you get 30. Like terms together, so you get 5X. So you have 5X, subtract 2X is equals to 30 minus 15. So brought 2X to the left hand side and then plus 15. I've taken it to the right hand side, like terms together. So 5X minus 2X, you get 3X is equals to, this is 15, that is subtract 15, that is 15. And this one gives X as 5, divide both sides by 3. So you're supposed to get the present age of the son, and the present age of the son is X, and that is 5 years. Question 17. During a by-election, only 62% of the voters in a constituency of 80,000 people cast their votes. Of the votes cast, 3% were spoiled and not counted. Candidate A got 48%, candidate B got 32%, and candidate C got the remainder of the valid votes cast. How many votes did candidate C receive? So that is a question. So we read again to analyze the question. So during a by-election, 62% of the voters in a constituency of 80,000 people cast their votes. So first of all, that will give us the actual number of people who voted. So 62%, that is 62 divided by 100 times 80,000. So it is only 62% of 80,000 who cast their votes. And when you work out that, this will give 49,600. 49,600. These are the one who cast the votes. Then the next statement, of these votes that were cast, 3% were spoiled. 3% were spoiled. So we need to get 3% of these. So 3 out of 100 times 49,600. We get how many votes were these? And this one will give 1,488. So 1,488. So these were spoiled. And then it means that they were not counted. So this one will give us the valid votes now. The valid votes that were cast and counted. Valid votes would therefore be, we take the total votes that were cast, that is 49,600, then we subtract the spoiled vote, because this one was spoiled, they were not counted. So 1488, and this now will give 48,000. When you subtract, you get 48,112. So now these are the actual valid votes. And this is what you're going to use in our calculation. Now, candidate A got 48%. So it will be now 48% of the valid votes. So 48 over 100 times 48,112. So that will give, so candidate A was able to get 23,000, get 23,093, and 93. You get decimal here, of which you're going to ignore 76.76. Because this one you're going, because these are votes, you're going to approximate this one and get 23,094 votes. Because these are votes, so you cannot deal with fractions and decimals in votes. Then candidate B got 32%. So that's 2% of the valid votes. So that's 200 multiplied by 48,112. So this gives, when you work it out, it gives 15,395. 15,395.84. Approximately, these will be 15,396. 15,396 votes. And then the remainder, whatever remained, was now for C, for candidate C. So for candidate C, we're going to take the valid votes cast total, that is 48,112, and then we subtract what candidate A got, that is 23,094, plus what candidate B got, that is 15,396, like that. So this is going to give us now the votes that candidate C obtained. So this will give 48,112. Subtract, when you add these, whatever is in the bracket there, you get 38,490. And these will give 96,22 votes. So that is what candidate C got. And the answer is there is D. next question. We go to question 18. Question 18 is the next. So question 18, the figure below shows 3 circles with center, the centers A, B, and C, given that, respectively. Then the two small circles touch one another at B, which is the center of the large circle. Given that the radius of the large circle is 28 centimeters, calculate the area of the shaded parts. Now, the shaded parts are not included. They are not you cannot see them well. So I'll just draw the shaded part, supposed to be like this. So these should be the shaded part. So the whole of that part, and then we have the other one here below. So these are the parts that you need to get. So how do we get these? By simply getting the area of the larger circle, and then we subtract the area of the small circle. So what is the radius of the large circle? It is 28. So we get the area of the large circle. So area of a circle is equals to pi r squared. So this will be pi, which is 22/7, times the radius squared, like that. And this one will give, when you multiply that, this will give 2464 centimeters squared. So that is the area of the larger circle. Now we need to subtract the area of the small circles. So since we have the radius of the large circle to be 28, so that means from this point here to this point, that is 28. So that means this is the midpoint of that. So this one should be half of 28. So this one will be 14. This will be 14. And also this one will be 14. This one will be 14. As simple as that. So therefore, we get the area. You can see these two circles are similar. They have the same radius. So we get the area of small circle. The small circles will be pi times the radius, 14 times 14. That is one circle. And then we multiply by 2 because there are two circles. So by 7, 1 by 7, 2. And this one, when you multiply, you will get, this one will give 1232 centimeters squared. 1232 centimeters squared. So now the shaded part will be given by the area of the larger circle, which is 2464 centimeters squared, minus the areas of the small circles, which we got as 1232 centimeters squared. So once you subtract these, you get 1232. It will be 1232 centimeters squared. The answer is D there. We go to the next question. The next question is question 19. So for question 19, the size of each interior angle of a regular polygon is 120 degrees. What is the name of the polygon? The size of each interior angle of a regular polygon is 120. What is the name of this polygon? For us to get the name of the polygon, we must get the number of sides of that polygon, and that will help us to name the polygon. Now, when you're given one interior angle, how do you get the size of one interior angle of a regular polygon? We'll get that on from the sum. Remember, the sum of the interior angles of any regular polygon is given by that formula. This is the sum of interior angles. And this is the sum of interior angles of a regular polygon of n sides. So if I want to get one interior angle, I will simply take the sum of the interior angles, that is 2n minus 4, right angle, like that, and then I divide by the number of angles. The number of angles, and the number of angles is equivalent to the number of sides. The number of angles is equivalent to the number of sides. I'll give you an example. For example, a triangle has 3 sides, so it has also 3 angles. A quadrilateral has 4 sides. It has 4 angles. A pentagon has 5 sides, so it has 5 interior angles. So the number of sides, which is n, is equivalent to the number of angles. So if I want to get the size of one angle, I'll take the sum of the interior angles, and then I divide by the number of angles. The number of angles, which is equal to the number of sides. That is why I've divided by 10. So this expression shows the size of one interior angle, and that is what you're given. It is 120. So just solve this equation. So, and how do you solve this? You first eliminate n, the denominator here, by multiplying both sides by n. You multiply both sides by n, like that. And when you multiply both sides by n, the n will get eliminated from the left-hand side. So that you have 2n, which you can multiply directly here. 90 times 2n, that is 180n, minus 90 times 4, this will give 360, is equals to 120n. Then, like terms together, you have 180n subtract 120n. You just bring this on to this side, and then take negative 360 to the right-hand side. It will be positive 360. 180n minus 120n, that will give 60n, which is equivalent to 360. So that means n is equals to, divide both sides by 60. So this will be 360 divided by 60. 360 divided by 60, and this will give 6 sides. To give 6 sides. So which polygon has 6 sides? It is called a hexagon. A hexagon. A hexagon is a polygon that has 6 sides. Pentagon has 5. Trapezium has 4 sides. Rhombus has 4 sides. So we go to the last question now. Let's go to the last question. We go to the last question. That is question number 20. Question number 20. So for question number 20, this is a question on statistics. So if 3 students score 60 marks in an assessment test, 4 students scores 70 marks, and 5 students scores 80 marks, and 2 students score 90 marks, what is the median mark? So this is what you're going to do. We shall simply arrange. So 3 students got 60. So that is a 60, 60, 60. Those are 3 students. Then 4 students score 70. So 70, 70, 70, 70. Those are 4. 5 students score 80. So 80, 80, 80, and 80. How many 80s? There are 5. 1, 2, 3, 4, 5. And then 2 students score 90. 2 students score 90. Like that. What is the median mark? So when you look at this data, it is already in ascending order from the smallest to the largest. So you have 60, 60, 60, 3 60s, and then we have 70s are 4, 1, 2, 3, 4. And then 80s are 5, 1, 2, 3, 4, 5, and then 90s are 2. So when you're getting the median mark, the first thing you should ensure is that the data is either arranged in ascending or descending order. This one is okay. This is how you get the median. The easiest way to get the median. The median is the middle value. The middle value amongst all these set of values that I've listed here. So just take that and that, because you want to balance both sides so that you can remain with the central value. So then this one with this one, 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 this one with this one. So you can see I want to get the middle value. That is why I want to divide this set of data into halves, into two halves. Now, since you have the 2 here that are remaining, these are the ones that are in the middle. You can see to the left you have 6, to the right you have 6 values. So these 2 are the ones that are going to give us the median. So use the 2, you get the average of the 2, 70 plus 80, you divide by 2. So this will give 150, 150 divided by 2, and this will give the median as 75. So that is how you're supposed to work out section 1 of that paper. Look out for section 2. I will make sure that I upload it very soon. So keep checking in the channel. I'll try my best and upload it